I feel that I ought to be actually talking about editing because I had so many questions for Sandra Adair and so many observations, one or two which may creep into this. But let's make a couple of quick observations. One is that the standard ways of handling, particularly dialogue scenes, hasn't actually changed in a very long since the middle 30s at any rate, and the way that Boyhood is shot is goes along with standard practice, in my opinion. And indeed, it's quite typical of present-day ordinary commercial dramatic films. I think the average shot length of it is probably somewhere around 4 seconds. I don't know, unfortunately, because I haven't analysed it. But looking at it last night, it looked to me as somewhere around 4 seconds, which is pretty typical. And although there's some awkwardnesses, the way the scenes are broken down, particularly the dialogue scenes, which are central, of course, you've got a lot more freedom in between that. Pretty similar to the old way, a little bit of which you're going to see in a film made 80 years ago. Anyway, let me press on very quickly. This is now called Latest Things instead of Latest Trends because I didn't end up with enough trends. I only got one. I ended up with only one trend, so it's Latest Things, and let me get right into it right away. So the first, there are 3 topics. The first of which is something that involves trends, and this is centers on autocorrelation, which is the same thing as ordinary correlation. You have a series of numbers, and another for ordinary correlation you have a series of numbers, and you have another series of numbers of the same length, and you can calculate what's called the correlation coefficient between them, and that's a number between +1 and -1, which gives you an idea about how similar the 2 series of numbers are. Now, what you can do with one series of numbers, like a series of lengths of shots, you can take that and double it and shift it and compare it with itself, and that's autocorrelation. If you think about it, it's obvious that you can shift the copy sequence one number to the right or left, and then or 2, and so on. And this is called autocorrelation with lag 1, lag 2, and so on. When the 2 sequences, which are the same sequence, are exactly superimposed, the autocorrelation will come out as 1. But that's neither here nor there. Well, indeed. When you have 2 strings of numbers, which won't happen with autocorrelation, which has absolutely no relation to each other. They're 2 random strings of numbers of the same length. In general, the correlation, not the autocorrelation, the correlation will come out somewhere near 0, which means that they have no resemblance to each other. Anyway, sticking with autocorrelation, this matter came up some time ago, and it has been broached on Cinemetrics already, and it involves the movement, or part of it involves the movement of the autocorrelation coefficient of lag 1, of course. That's the simple one that you concentrate on over the years, and it arose from James Cutting's data, which he kindly provided to Cinemetrics, although the latest batch is not actually on there. The 2010 data, which he again generously sent to me, which I've used, is not on the Cinemetrics site. But anyway, when you look at it, you look at the various quantities, the ones that James Cutting and his collaborators were interested in, which is the auto-regression coefficient, which is called AR here, and the slope, which I'm not going to try and explain to you, which is what he was concerned with in the first place, and that, oh God, this thing doesn't do a pointer. A mouse pointer. Well, I'll just go over there. So that's the slope over the years from 1935 to 2010, and in my opinion, it's pretty flat. That's a degree six polynomial fitted to it, and in my opinion, that's pretty flat. And then you've got the AR, which is the green ones, and that rises over the decades, over the years, and you've got a couple of other things, the MAR, which I'm not concerned with, and we've got the cutting rate, which is here, and the cutting rate is the inverse of the famous average shot length. And it's the plots here are scaled to come close together. So what's plotted there is, for instance, is not the actual cutting. Where'd it go?
Don't fall.
The top one is not the actual black one. Is not the actual cutting rate, which is the number of shots per minute. It's 10 times that. Don't worry about it. This is just so that you can see the way they're going together, or not, as the case may be. Now, the peculiar thing about it is the autocorrelation coefficient of lag1 plotted there, and certainly it appeared, and this is on Cinemetrics somewhere, I can't remember, in one of those discussion articles, that it's started decreasing, according to this, in 1990. And this is very strange because the cutting rate is still going up. And now I'm probably the only person who's worried about that. But nevertheless, this is what investigation and even scientific investigation is about. I put in the 2010 data from James Cutting, of course, and I checked the autocorrelation coefficient from my data. I have on the site in my database, I've got, amongst other things, 80 films, complete data for not just the cuts and the cutting rate and the camera movements and everything. A series of analyses for 1939, 1959, 1979, and 1989, and they're the green dots, separate green dots that you see there. I calculated the autocorrelation coefficients for all those films, 80 films, and you can see that it's not the series, the four, is not rising in the same way that the data from James Cutting's films, which in total, of course, are a larger number. I don't know what is it, 160 or something. But they're also the way the samples are obtained is different. James Cutting's ones, certainly from 1980 onwards, are more or less the top 10 box office films, and in general that was the idea, that the top 10 box office films would be analysed every 5 years. And he and his associates did this and got the result, which is the blue dots with the black line between them, which was on the previous graph. And my films are a sort of a more or less random sample, 20 films from 1939 and so on. They're not the top ones, but it is a slightly bigger sample. So what this means is that I would say is that there's at least a question over whether the autocorrelation coefficient is really has really risen a lot over time. And that's the point of this particular investigation. You can see that the cutting rates, the James Cutting and crew's cutting rate is the black ones, and that's mine, whatever colour it is, pink, mauvey pink. And you can see they go, of course, quite well together. They even coincide as it happens up the end. So that's very nice, but that's not what I was after. So I think there's a question, at least, over whether the autocorrelation coefficient is indeed increasing. This, as I say, I'm probably the only person who worried about it, so let's leave it there. But something else that comes out of autocorrelation, which is important in general to cinemetrics, is that there is a difference, I think a significant difference between the results which shows up between frame accurate analyses of shot lengths, which is what I and James Cutting are involved with, and the cinemetrics business. And I predicted, I think it's somewhere, maybe it's in one of those articles on the site, requiring split second timing. I think it's in there. But anyway, I predicted that for fast cut films, that using the basic Cinemetrics device and hitting a button every time you see a shot change, when you get fast cutting, the rhythm, you get a body motor rhythm cutting in there, and it's not as vanishing. And this is shown, I assert, by these results that I'm just going to show you. So the important thing is to look at lag 1, don't worry about the rest of it. And you can see this is done for Dark City by me and by Eric. Use the basic Cinemetrics way. And the average shot length of Dark City is around 2 seconds. You know, it's right up the top there. It was up the top at one point briefly, but it's not any longer. But its average shot length is I think maybe slightly under 2 seconds. It's very close to that. So this, if you look, I'm sorry, my one. You look, you see. I get the autocorrelation, it says correlation, but that's the autocorrelation, of course. 1 is 0.27 to the first couple of figures, and Eric's is 0.37. Now that might seem a lot to you, but in terms of correlations, autocorrelations, this I'd say is significant, and is what you'd expect. it happened, the body motor rhythms take over. Now, this persists, actually. It's slightly slower cut films, and this is me and Mary Lou DeHaan, I think, doing Ed TV, where the average shot length, I think, is about somewhere around 4 seconds. Which, as I said, is fairly typical nowadays. This is 1999, of course, never mind. So I've got lag 1, 0.12, rounding it down. Oh, that gives it the same as Mary Lou, but I'm going to take it to 4 figures, and you can see that hers is a bit bigger. And then we come to 10 Things That I Hate About You, which is mine and Eric again, and this is average shot length around 6 seconds, something like that. And I've got 0.238, and Eric's got 0.241, which is, I'd say, significantly bigger, and in this particular case. So this is a awful warning, I've got to say, about using a lot of the cinemetric results for autocorrelation. For other purposes, it doesn't matter probably, but there you go. While I was doing this sort of thing, I did, of course, check whether the autocorrelation coefficient on its own or was enough to characterize a particular director's work, looking at from a style point of view. And it's not. It varies between appreciably between different films with the same director. I'm not saying don't investigate it any further, but I don't think it's promising as a style characteristic. There is, with films, there does seem to be, to a certain extent, two classes. Those where the autocorrelation coefficient falls off very quickly from lag 1 to lag 2, and that's the case with this. You can see 0.23, and then it goes down 0.03, the second lag. It's gone right down. Now, there's a very large bunch of films that are like that. However, there are also films where it goes down, but a large bunch of films where it goes down. Let's see if I can find one. That EdTV, it goes from 0.11 to 0.09, which is not very much, and then it starts falling. Let's look at the other one, Dark City. That goes down much slower. Now, there might be something in there, separating out these groups. What it'll tell you, I don't know, and I don't think it's that promising. Anyway, let me rush on to topic 2, which is something which I've done before, but which I've tinkered with a bit. And if I was Robin Hood, I'd be splitting the arrow, so to speak. And not shooting arrows at a blank wall. Okay, so I did Darby O'Gill already. It's on the website. I forgot what the title of it is, but it's there. And I've added Robin Hood for certain reasons. And the idea is that, well, perhaps I better say how it's done, because there's a slight refinement there. I think I did two moving averages, one on top of the other, applied them to the data initially. Now I'm doing 3 moving averages, or rolling averages, or whatever you like to call them, on the shot lengths. And the shot lengths are the black lines. They're up the standard way, not the cinemetric way. Okay, that's the shot lengths. And then you've got the green line, which is a moving average, a filter applied 3 times first of all over 10 shots, the moving average from 10 shots on either side of the point plotted, and then that's fed into, that's removing average with 14 shots, and then that yet again, that's done yet again. You could go on, of course, but I don't think there's any point going further than this. And it's an hour moving average over the much jumpier, the much bigger range of the actual lengths of shots. And there's a reason for doing this. And that is coming out already, I hope, in this graph, which is I've plotted for each scene. I've taken the scenes, the series of scenes in Robin Hood, and these are quite pretty definite. And I'm using scenes in the sense, the dramatic sense, which quite often coincides with scenes in the film production sense, which is, of course, one of the things that we're concerned, Sandra Dare is concerned with, the only thing she's concerned with, actually, in this respect. So there's an average shot length over the length of a complete scene, as well as the whole film, which is what we're ordinarily talking about with average shot length. And I've calculated that for the series of scenes, and they're appreciably different. So that you've got the first couple of scenes there, which have sort of run together. Then you've got this long scene, which goes on for 15 minutes, which is very unusual. Scenes in films, and indeed the film Boyhood you saw, are usually about the order of 1 to 2 minutes. You do get a few longer ones, but you certainly do in Robin Hood. So you've got this big scene, first scene in the, I'll remind you about it, I'm assuming that everybody's seen The Adventures of Robin Hood, but you'll get a teeny reminder about it in a minute with any luck. That's the scene in the castle hall where Robin Hood comes in with the stolen deer and ends up with a big fight as he escapes, fights his way out of the hall. And you can see that here. This bit is the fight, and the shots are much shorter here than they are in the earlier part of the scene, which is a dialogue scene, which goes on, that part of the scene goes on for about 10 minutes. But it's interesting all the way through, and so on. And then you get this, that, and the other, most of which doesn't concern us. And you can see that the scene average there is higher there and lower there. And the average length of shot in the scenes tends to alternate in most films. And this is a part of standard film construction since practically the beginning. And somebody may be actually going to be talking about this because we've got that article by D.W. Griffith in which he retails the idea, which was already standard in the 19th century, about the idea of alternating the mood of scenes in a play. And hence in all these people, Griffith and lots of other people, did it in films when they were writing film scripts. And it carries on. It's weakened a bit in recent times, but it's still there, as you'll see in a minute. Okay, so this is the first go at it, and you can see there's a sort of correspondence between the green, which goes up and admittedly goes up and down, and the red, but they've sort of lined up. In other words, this moving average distinguishes to a considerable extent, I'm asserting, between scenes. So let's look at some other ones. But there's a refinement to it. This is the same thing, but now I've divided those long scenes into parts. And in the case of the first scene, you've got the long dialogue part, and then you've got the action part. And I've calculated the blue line average shot length for those parts of the scenes. And now you can see there's a better correspondence between the green line. So I think I may be getting somewhere there. But anyway, let's look at a couple of other films more recently. And you can, it's a bit, because the number of shots has gone up, it's got a bit dense with the actual black lines of the real shot lengths, but it's working, and there's still, if you look very carefully at for the red, you can see the alternation between scenes of length, of average shot length over the scene, and that's Mr. and Mrs. Smith. This is James Cutting's data again, actually, not mine, but it's good. Thank you. And there you go again. All right, so my idea, which I maybe haven't articulated before, is that scenes are real, but acts are not. I would very much have liked to ask Sandra Adair whether Richard Linklater ever talked about acts when he was writing his films. In my experience, most filmmakers, as opposed to producers like talking about acts, and people who write books about how to write films, who are virtually never real film script writers, like talking about acts. But I don't think filmmakers talk about acts as far as the construction of their films are concerned. And that's what I say, scenes are real, acts are not. When real filmmakers, well, producers talk about it, they always talk about 3 acts, incidentally, in a vague kind of way. I mentioned this to Mike Lee once, and he said, yeah, my films have 3 acts, a beginning, a middle, and an end, in a sarcastic way, and that's about it. So, how are we doing? I've overrun
already. We save on questions, like 5 minutes?
I haven't finished.
Oh, so why are you asking?
Yeah, I'm asking because it's a bit more. So, okay.
So are you finished, or you want to say?
I haven't finished.
Oh, you haven't finished?
No. Okay, so this is another way of looking at it. And adding something else, adding the closeness of shot, which you've got to know about this. That's my diagram, and you can make up your own. As long as you define it properly, I don't care. As long as you define it and can communicate your definitions to other people. But if you don't, it's not so helpful. You can convert between the two approximately. So there's the big close-up, and so on for the whole of Adventures of Robin Hood in blue. And then we've got some of the scenes, which I was going to show you, but I'm not now. Because, damn it, I'll spend a minute or two on this. You come 5,000 miles to do this. Here we go. Let's see if I can get this out. Now this is the scene I was talking about in the first place, the big scene in the castle hall, and it goes on the dialogue, and then eventually we have the action, and they escape, and so on, so on, and so on. And then we have this comic scene with Friar Tuck, and then what I'm talking about is, there's some archery there, real targets. Okay, here we go. So, just a little bit on from that. So, we've got the scene where Marion, Lady Marion, as she's in the film, is Robin Hood's been trapped, he's in the dungeon, and Marion has a consultation with her nurse.
What is it, friend?
A lady, sir. The Lady Marion.
Yes, Professor.
What? It's a trap, Will.
Then we've got this
Watch those
scene,
windows. She has the
which is
password,
an
all right.
ordinary dramatic
Is
scene.
she alone? Yes, sir.
And
Let her in.
actually, this is one I would start with something, but and ordinary dramatic scene where she approaches the outlaws, although she's part of the nobility, and
What do you want, milady?
I want to help him.
How did you find us here?
Never mind that now. Please don't stand there staring. Tell me what I can do.
Don't trust her. It's another Norman trick.
Would I come here alone if it were a trap? What's to prevent your keeping me here and killing me if... Oh, is there no one here with sense enough to see?
One moment.
comes out with a plan, which we don't hear, and then we get to the execution scene. Activated. Where's a bit of execution After that, we have a romantic scene. It starts out without the romance, although they're talking about romantic situations, and then Robin Hood comes in and pitches woo to...
But I can do my best.
Bess, will you leave us? Please.
Now let's see. Where does this game begin? Oh, I know. It's simple. We'll start where you're in love with me. You are, aren't you? Because I am with you. Terribly. That's why I came. I had to see you again.
You must go at once, and I don't love you.
Oh. You sure?
Yes.
Very well, then. I'll go.
and so on.
This is rather unfriendly of you, exposing me to my enemies like this.
Okay. I think that's about it. Let's see. Where's the up there? The blue one. There we are. And there we got that. Back to there. Yeah. Okay. And we can see that the cutting rates are substantially different. So they're 8 seconds, which is much slower than the average. The average for Robin Hood is about 4.7 seconds, something like that. So that's much slower, dramatic scene. And then we get an action scene, scene 2, where it goes to faster, naturally enough, than the average, 3.5 seconds. And then you get the romantic scene, where it slows down again to appreciably slower than the average. So that's the Friar Tuck comic scene, which is around the very, very close to the average as it happens. And then you've also got the overall closest shot for the film, and for each of the scenes, which is appreciably different. It has to be said. It also distinguishes amongst the scenes the profile of person shot. Here you've got that's the Friar Tuck comic scene. You've got a great deal of most of medium long shot, whereas in the romantic scene, interestingly enough, you've got lots of close-ups and so on. And they're very easily distinguished, these profiles. You can do a mathematical analysis of them, but I think, as Mike Baxter did with respect to something or other, some Fritz Lang and so on films, which is on the website. But it's not necessary, in my opinion, but fine, you can do it. I think it leaps to the eye myself. So that's something which I've, of course, started doing about analysing scene by scene about 30 years ago with respect to some Max Oppolz's films. And finally, a bit of auteur stuff. This is the the scale of shot profiles for 20 films from 1979, which the sample which I referred to earlier in this speech. And you've got a bunch of Woody Allen films, which are not all from 1979, one of them is, and you can see that they have a fairly similar shot scale profile, but it also happens to be quite close to the 1979 average shots, averaged all over those 20 films. But the shot in the locker is the difference in average shot length, because nearly all the other nearly finished, and all the other 1979 films are cut much faster than the Woody Allen films, which you know are sort of around 11, 18 seconds, that kind of thing. And there's a bit more camera movement. I haven't talked about camera movement, but there's a bit more camera movement in the Woody Allen films, but not a lot more than the average, actually. So the fingerprint, the blurry fingerprint of Woody Allen is, I think I've distinguished it. So I haven't given up on my basic idea about statistical style analysis. Those are incidentally are the average scales for 30 to 39, 59, 79, 99, and you can see how it's swung from fairly even with a bit more emphasis on the long shot, and swung till you've got by 1999. It's pretty much the same now. It probably hasn't, it may have increased a little bit. A heavy emphasis on close-up. Now, this was all known before, of course, but it's enough to go on with. And now it's lunchtime.